Hello guys. I wanted to make another video about a task that I had to do recently. I thought it was pretty interesting. I wanted to share it with you. Customer contacted me and asked me to review a set of approval drawings for another detailing company. These drawings went to approval, got marked revise and resubmit. The detailer made the changes and then I was tasked with just reviewing the approval comments and making sure everything was addressed. While I was doing this, I did the task, but then I went into the design drawings a little bit deeper and I noticed some things on these detail drawings that I wanted to share. So I'm going to get in here and show you a little bit of what was going on here. I'll start with this this RAB 108 here. We go to that detail. Oh, that's not it. You'll see this little plate here. This plate is supporting a doorway currently. As you can see in this view here, it's supporting this brick above the doorway, but there's no plate to support this brick over here. I'm kind of puzzled by it, that why you would only support this portion but not this portion. there's no lintels. I ended up finding that there was no lintels on the project above any of the openings. Um, and these plates, the plate that I'm talking about now, is missing in the locations where it was required on the project as well. So I'm just going to go through the architectural views here and kind of show you all the openings that didn't have, like at this location, this is all brick, and above all these openings there's no support for the brick. So yeah, none of these openings had any support. So come back over here. I tell them that this plate isn't long enough um, above the windows. So then go to their drawing here. Now they revised it, extended the plate, but now they extended the plate past the column, and I have that drawn here. Like this, these two blue lines roughly represent the column, and you can see that plate's extending out all the way to the corner, but then there's no support. There's no support on this column, and you can see that there's no support on this beam supporting this plate. So any of this brick that's out here above the window, all that load needs to transfer back into this beam. Um, and this up here is just a top view. This is like a view of the brick, and then how you can see that it's probably more like this. But then it wraps, I guess, like that. And then there's another beam on this side with a similar plate that extends over. So yeah, ultimately that's not ideal. Like you don't want to cantilever this out without supporting it somehow, and they're just not doing that. They need to do that. Another issue that I've seen on this detail, well, just real quick, this cope that they're putting in there, this should always be radius. This should never be cut at a 90-degree angle like that. Just because this becomes like a weak point of this plate. Any copes need to be radiused, and any detailer should know that um, when they're doing this type of work. Um, Again, here's another thing. Here's an angle. This is what the connection looks like. Um, where you're going to have a column and then you're going to have an angle below it, or a seat, some type of seated connection. Um, there's no erection bolt for this. So basically, this detailer is assuming that the erector is going to bring this beam in, sit it on top of this angle, and just like I'm sure they have a field weld detail. I'm pretty sure I've seen it. It's been a while since I did this, but I know they have a field weld detail. It's just not. They just don't have any erection aid, and that's the main point of this. Is because you need an erection aid with this type of connection to make sure it's it's held in place. So um, just so the erection crew can set this down, stuff that bolt in there, so to secure it in place until it gets field welded, and they can move on to the next piece. This detailer did not do that though on this project, and that's an OSHA thing, that OSHA requirement. So most of these other comments on the plans are all about lintels and these plates. Another thing with these plates is they're not at the right elevation. The detailer just put in the beams at the elevation that was shown on the structural drawings, but the when you lay it out to against the architecturals, the beam's not at the correct elevation because they want to they want the plate at the top of the window. And right now, the way this detailer is doing it is it's encroaching into the window. And I'll show you that here. One of these section views. Actually, it's on the structural drawings here. Yeah, so they're showing the bottom of the plate at the top of the window, and that's just not what's happening. This plate, the way the detailer currently has it drawn, is down here, and then this beam is down lower. And this isn't like this video shouldn't reflect bad on the fabricator or erector or on the design team, because as far as I'm concerned, they got their hands full and they're paying detailers to do this stuff, but detailers just aren't doing what needs to be done on the projects a lot of times. I can't speak for all of them, but I know from my past experience at my last job, seeing it on this project, seeing it on other projects. That's I see it a lot, and I don't understand why. Because in reality, if I go back to these, so in reality, what would end up happening is all this steel is going to get erected for this project. Then the mason's going to come in and start doing his thing, erecting all the masonry work. He's going to get to the tops of one of these openings and realize, hey, we don't have any support above any of these doors or windows. Then he's going to contact the GC and then the GC is going to contact the fabricator, and then the fabricator is going to call the detailer, then the detailer is going to detail everything, and then like while that's happening, the fabricator is going to be trying to get material, but he's waiting on the detailer to find out what material he needs, and then the fabricator finally gets erection drawings or fabrication drawings. He fabricates all this stuff. Then it's got to go to Galv, and then you got to pay for another truck to go to the field and carry all this stuff. Then, if those plates need to be welded to the beam, somebody's going to have to pay that guy to do it. All meanwhile, the mason's on site waiting to lay this brick down, and they can't. So, just through all that, you got so much time and money into this schedule just from these errors, and I don't understand it. Like I see more and more detailing companies taking their work, subbing it out overseas, and then selling it back to fabricators. Like they got the best, they got the best deal in the world. Like they got the price and time, like schedule wise. But then in reality, when you get down to it and you get to actually doing the project, you get errors like this that cost the fabricator money and delay the schedule on the project. So you're not benefit by by using these guys. I don't understand what you're doing, but yeah, that is not ideal in my opinion. Like I don't know. I would lose sleep if I missed stuff like this, but I don't because I look at every project. I'm looking at the structurals. I'm looking at the architecturals. I'm thinking about erection. I'm thinking about so much more than just what's shown on the plans. And sometimes that doesn't get communicated to fabricators. Like they're like when it comes bidding time on a project, they're just looking at what's on the drawings and what's the cost and how long is it going to take. But from my standpoint, like I'm looking at on the drawings what's there, and if I get awarded the project, I'm looking at how's it going to be erected. Just coordinating everything, just making sure everything goes as smooth as possible from erection to fabrication, from every aspect. I'm thinking about the other trades. I'm thinking about mechanical. I'm thinking about masonry. I'm thinking about the other contractors. I'm thinking about order of erection. I'm thinking about sequencing. I'm there. It just there's so much into it, and that's why I titled this video "There's levels to this stuff" because like there's a lot of detailers out there, but they're not all the same. There's a lot that are not doing the same work that I do, or I know there's some others out there to do. I'm sure. Haven't met a lot of them, but they're out there. I mean, I learned from a lot of these guys. Just to give you a little bit of background real quick. I worked with a lot of guys that learned from guys from American Bridge. American Bridge was like the first guys to do it. Like they're drawn on paper, everything. They were hand sketching. They were sketching everything out, and they'd hand their drawings off to like their female coworkers back then, and then the females would rewrite everything because they had the cleaner handwriting. And these guys were using slide rules and just doing everything by hand, and the drafting rooms were huge. And then these guys took their information from American Bridge and handed it off to the younger generation. And then that generation grew up doing a similar thing, but then getting into computer aided drafting and ultimately handed it off to the next generation. That's kind of where I fall into this. And so I like to think that I learn from the best. I mean, these guys were really good that I learned from, so I'm just kind of sharing some of that knowledge here um, back with you guys. So um, I'll continue on here with some of the other things that I was seeing on this. Let me get over here. I'm doing this in one take. I'm not editing it, so bear with me. Bear with me. So we covered there's no lintel, there's no brick support on this project. That was provided by the detailer up to this point. And then what was provided, in some cases, it's not supported, so it's not good. Here's another issue that I seen where you got some rod bracing. You got a clevis and turnbuckle. These turnbuckles are all located right here in the center, which make it a real pain for the erector to tighten down with this other rod being there. Like you can't, you probably could turn the turnbuckle, but it's going to be a real pain in the ass, and it's like that on every single brace bay on this project, which there's quite a few of them. And I'll flip through here, showing you all these different brace bays where it's not ideal. And then also just another thing, just briefly, like none of these connections are designed. Like I mean, they're designed like the design team designed them, but like the software, these guys are all using Tekla. A lot of these overseas companies are using Tekla, and it's just not good. Like they're just, in a lot of the cases, they're just putting in material and calling it good. It does have capabilities to do connection design. Like there's like some, from what I understand, there's ways to do it, but a lot of these companies overseas don't, and they're just kind of flying by the seat of their pants. I don't know. Not ideal. Not ideal. But ultimately, yeah, you can't tighten these properly. You could put the one in, tighten it down, and then add the other brace, tighten it down. But in my world, what the way doing thing doing things properly in my mind, you don't want to have the erector have to do anything in any particular order unless you absolutely have to. And you want it to just let him do his thing, and it should all work out. You don't want to, I guess, tie his hands too much, making him do a bunch of certain stuff, certain orders. Everything should just go together, and everything should be smooth. Here was just a general note. I think there's additional steel that needs to be provided on the bottom side of this beam to support more brick that's on top of the roof. That's like, it's currently just going to rest on top of the deck. I don't know if that's what the customer wants or what the design team's intent was. I think it's supposed to be something more like this detail here. Um, and that's why I was questioning if it was required because it's not really clear on the designs, but that's something just the detailer should have asked and should get cleared up, but they haven't done that up to this point, and this is now the second set of approvals. They should have done that on the first set, in my opinion. Here, just a bad weld, um, and it's never good to have bad weld signs because like the guy on the shop floor is not going to know to ask that question. He's looking to you saying, okay, that's good. So he doesn't have anything to compare it to. He doesn't have the designs. He doesn't know. So you want to make sure that you're providing all the right information. Same here. That's another another note to check to see if more additional steel is required. Here's that. That's that double-sided fillet we just talked about. I'm just looking for more comments. Here's one. So on here, just flipping through another screen, I'm gonna show you the condition here. So here's the condition of what I'm about to show you next is where we have a beam and then we have a tube on top of that beam. And these joists need to bear on the beam. So if I flip back over to that detail here, you can see that there's no room for that these joists to bear. Like there's just no they didn't account for them at all. They didn't account for any of the joists. So either one, the erector is going to set the steel and at some point realize that it's too high, or they're going to set it and know that it's too high and then have to cut all these tubes, notch all the tubes at every location where every joist sits. Regardless, there's not a good answer to the fix for this. And again, I don't understand how you're detailing and you're not aware of this stuff. And this is just stuff that I noticed randomly. These kind of, I don't know. I'm not gonna get into that. But I'll show you real quick what that detail looks like here in another view, or on the updated set of drawings here. So this is that same detail with that tube, but you can see how it's notched now to give room uh, for the joist to attach. So you can see how much different uh, what it is now versus what was required, and then this is the work that they would have to do in the field. And this isn't the only beam that's like this. There's several of these beams that had that issue. So let's go to the then here. This is the end of the clevises. They're not telling them how wide to make this grip here on their detail drawings. That's that's just information that needs to be known, and like that's like that on every detail. And there's some with, I don't know, the clevis is just not right at all. I was looking for one of those. Like this guy here. Like, I don't know what that is, but that's not right. So there's another, you know what, what was it? There's one other thing on here. So here's this guy. So here's another one of the plates that we're adding on the bottoms of the beams. This is on the updated set where they added the beams in. Or added the plates in. They have this 1/4 inch fillet weld here. Not an issue, but this gap's only a 1/4 inch currently here, and you need at least an extra. You need an extra 1/16 inch on a weld that size, um, just to allow the shop enough room to lay the weld. Um, and then another thing, whenever you're doing pieces like this, anytime these pieces get rolled, these flanges are always wider than they're. I'd say more often than not they're going to be wider than what's shown in the AISC manual. Like the AISC manual says like has a flange section, but they're not always that because when these things get rolled, the extra material comes out here in the flanges. So these flange widths grow and they vary, and that's why you never dimension off them like I'm showing there. You don't do that, but at the same time, there needs to be at least an extra 16th of an inch here, and I would say even more than that based on the way these just from the fabrication tolerances of the wide flanges themselves. So that's what I found on this project from another detailer, and um, just as like another note, I'm not sure if I covered this previously, but this is a different project that I did, and I'll show you like something that kind of I don't know that I noticed on a project when I was going through. Um, on this project, these posts were down in a little pit area. You got these posts down here, and then you got the beams sitting on top of the posts, and there's quite a few of them. There's a lot. There's like 200 and some posts. Um, yeah, it's like 250 or something like that. I want to say of these posts. And they're all sitting down in this pit, and this wasn't noted on the design drawings or anything. But when I was going through modeling this stuff and like thinking about it, detailing it, and I was like, well, these two, well, this bolt up here and then this bolt down here, there's no access to them once they're down in this pit and this beam's erected. So the erector is going to get all these columns in and then go to sit these beams on there, and then they're just not going to be able to put this bolt in and tighten it down. So I went ahead and shop attached these bolts to the beam and up here and down below. This bolt wasn't even in our scope of work, but since there wasn't access to it, we picked it up in our scope of work so we could shop attach it before it went to the field, just so the erector didn't well so we could shop attach it just to make erection easier. Um, and I was pretty happy with this because I was finding like I found this erection issue that could have been a real issue if it got to the field like that, and then the erector sitting out there locating all these nuts and bolts and shop attaching them to the beam when they're thinking they're only doing erection, and then not only there's like a cost involved with all that because you can see like all these this hole here, like these are all those bolts. So then there was like I want to say like 1,000 bolts or something that they shop attached, and then like 500 of the nuts on the inside, like 500 of these and like 1,000 of these, and that would have been a nightmare for the erector, and there would have been cost associated with that. But I noticed it beforehand. We addressed it, got them accounted for, and then we ended up putting them on in the shop. So just something I'm really happy about, and I wanted to share that with you as well. Um, and yeah, that's pretty much all I got. Um, Again, it's like sometimes like fabricators don't think about it, but there's more that goes into this than just like price and timeline. To actually get something done like this saved so much time. Like imagine if like this didn't get, something like this didn't get noticed, like those lintels and stuff, and then they make it to the site like that. Well, maybe the fabricator has time to erect this stuff, and he holds off. He erects it, and he gets it to the site on time. Then they go to erect it, and they can't. The erector can't, and then they gotta weld all these nuts and bolts on before they even do the erection process. And you can just kind of imagine there how much time you're adding to the project, time and money to the project. So there's benefits to getting detailers with experience and uh, yeah, the guys that are actually putting time into it and thinking about what they're doing here because it could really save you in the long run. Um, if you like what I'm doing, you can feel free to reach out. It's Precision Steel Detailing LLC. Thank you for watching, and until next time, thank you.